One, two, three.
I've been seriously impressed how well a micro quadcopter can fly using just a single 18650, but it has its limitations. The lower voltage mixed with a higher weight can only do so well. Which brings us to today's question. What if we put two cells together? Will we get double the power, or will the extra weight totally negate any potential benefits? Today, let's build a quad and put it to the test. I was originally going just to throw some parts together like I normally do, but I realized this build's gonna be very different from my previous ones. This battery is twice as heavy, takes up twice as much space as a single cell battery, which caused some serious challenges right from the start. I've used anything from a 45mm prop all the way up to 3 inches, and that has been more than enough for my needs. But with this bigger battery, I decided we're gonna have to step it up and use a 3.5-inch propeller. So I went looking for a frame that was strong, lightweight, and had the correct mounting holes. Unfortunately, nothing checked all those boxes. Most 3.5-inch frames have bolt-on arms and double stack configuration that adds too much unneeded weight. I wanted a single piece carbon design to keep things simple, and after searching for a while, I just gave up and decided to design my own 3D printable frame. I mean, how hard could it be, right? Well, let me tell you, I was completely wrong. My first few prototypes were insanely flexible and way too weak. There is a huge problem with 3D printing quadcopter frames. The material isn't nearly as durable or stiff as carbon fiber. I had been designing the frame like it was carbon, but after a lot of trial and error, I finally landed on a design that was much stronger. I found that keeping the outline thinner and reinforcing key areas made a huge difference in stiffness. I also hollowed out the bolt mount holes, which helped shave off a little bit of weight and let me use shorter bolts. The final weight came in at just under 15 grams. The battery holder turned out great. It slots right into the frame with a built-in VTX and GPS mount. On a lot of my previous builds, I have loved this all-in-one matrix flight controller. However, it's only for 1S builds, so I decided to try something new. This is the Darwin FPV 15-amp all-in-one flight controller, and on paper, it looks too good to be true. It comes with an ELRS receiver that's built in. You simply plug in the antenna. It's a T antenna, which will give us way more range than the enamel wire antennas. Comes with an XT30 plug, which is exactly what we need. You can run 1, 2, 3S batteries, which gives you so much versatility. And while you do need an external VTX, I actually would rather have it that way so I can choose whichever VTX I want to put on it. And since this is a little bit bigger quad, the extra weight shouldn't really matter. Now, like I said, this sounds too good to be true, so we're gonna try it out and see if it works well. Using this HGLRC Zeus Nano VTX, it's pretty cheap, around 25 bucks, 400 milliwatts of output power, and this time I'm gonna be trying a lollipop antenna to see what kind of range we can get. In all my previous videos, I've either used the CO3 camera or the Caddx Ant Nano. These cameras are ultra lightweight, but the quality just isn't that good. So I decided to get the best nano camera you can get, which is the Caddx Ratel Baby 2. This camera does look pretty cool. It has an extra PCB and a better sensor. People say this is the best you can get at 14mm. However, it weighs twice as much and also costs twice as much as the other cameras. So we'll test and see if it was actually worth it. Meps King was kind enough to send me these motors to test, and at first look, the quality just looks great. I was really impressed when I went on their website. The prices were super affordable too. So I am super excited to try these out, and Meps King actually gave me a 10% discount code. If anyone's interested, it'll be in the description. It turns out it's pretty hard to find 3.5-inch bi-blade props, but I ended up finding some. They're HQ 3.5 by 2.2. So we'll be trying these out. Again, weight isn't as much of a factor here, so I'm gonna add this GPS so we can do a proper range test. I have these bolt kits, which I would highly recommend getting a couple because I used a ton of stuff from both of these. These are Nylon M2 spacers, comes with some nuts and some bolts as well. Then I have metal ones and just a bunch of different size of M2 bolts, and you will need them. I have tested a ton of different cells to find out which ones are the best. My findings are very simple. The higher the discharge rate, the better the performance. These two cells have under 20 amps discharge rating, so don't even bother. These three, on the other hand, are all rated over 30 amps. The Molicel P28A is the best budget option, but it doesn't work quite as well as these two cells. These have a tabless design, which is new technology that allows an 18650 to have a great discharge rating. This one is the AmpAce JP30, which is super popular, 36 amps discharge rate with a 140 amp burst. And then there is the newer Eve 30PL, which has a 60 amp discharge rating and no burst rating. However, this is my new favorite cell because it's almost 4 grams lighter than the AmpAce JP30, making it perfect for micro quadcopters. I made this 2S pack from the Molicels. I'll be comparing it against these Eve cells. For building the battery, I used a mix of electrical tape and heat insulation tape to protect from shorts, pure copper strips to carry the high amperage more efficiently, then I soldered on the battery leads and the balance leads. One going to the positive, one to the connection on the bottom, and the last one to the negative. An XT30 connector will be perfect for our needs. And there you have it, an ultra high discharge 2S lithium ion battery. The soldering for this project was a little difficult. The flight controller pads are pretty small and the wiring diagram is a bit confusing, so I'll definitely link one below. I guess you get what you pay for a little bit because they wired the XT30 plug backwards and I plugged it in wrong, but luckily I used a smoke stopper and I did not get any magic smoke. Owning a 3D printer is nice because I can redesign this frame and print new ones. But it wasn't that long ago that I didn't even have a printer. I had tons of ideas, but no real way to turn them into physical parts. That's where JLC 3DP comes in. JLC 3DP makes it possible for anyone to bring their projects to life with professional grade 3D printing. I simply sent them my quadcopter frame design, and production was complete just a couple days later. Not long after, I received these beautiful, flawless nylon frames. And it's not just for drone parts. They offer over 20 material options, including engineering-grade nylons, metals, and plastics. So you can choose the right material for any project. Unlike using a personal 3D printer, where the print doesn't always turn out, when using JLC 3DP, you know you are going to get a perfectly finished product. One of the best parts is new users can get up to $123 off their first order. So don't let not owning a 3D printer stop you from building your dream project. Huge thanks to JLC 3DP for sponsoring this video. Their support is what makes videos like this possible. I was very happy with this weight. And maiden flight was a success. But I quickly realized we had a big problem. No OSD, meaning I couldn't see the battery voltage and wouldn't know when to land. Turns out it was an easy fix. I had tried to connect the video transmitter to a UART, and this flight controller doesn't work like that. I needed to connect the RX of the video controller to the smart audio pad on the flight controller, and that fixed it. I got the on-screen display working, but it was having a hard time getting enough satellites. Even with the VTX powered all the way down, it was having trouble staying above 8. It turns out these were the culprits. The GPS and antenna were mounted too close together, and if the antenna is too close to the GPS, there's too much interference for the GPS to find those satellites. With how it was mounted before, there was 4, maybe 5 centimeters of distance between them. So I redesigned them with this little extender to get the antenna further back, and I extended the GPS forward. Now there's about 7 centimeters of space, so that should be a lot better. Let's get back to flying. And liftoff. The OSD is working perfectly, and I am super excited to fly this thing. The first thing I'm noticing is the throttle idle is so much lower than with the 1S builds. I'm hovering at 27% throttle when the 1S builds hovered around 45%. This translates to so much more power. One thing I was worried about was the handling with this 3D printed frame. It was flexible. I was worried there would be some pretty bad vibrations, but it actually handled super smoothly. Now the question just is, how durable will it be? The analog still makes it difficult to see these tree branches. I really was just having a great time till... and first test run cut short. That answers the question about durability. Just totally shattered. Look at this arm, the body, and the camera mount. Camera's a little beat up here. Antenna plastic snapped, but I think it'll still work. To fix my design, I simply just thickened all the arms, went back in and reprinted it, and I'm hoping that will give me the durability I want. Here's my original design. Here's the new one. I added about 1 millimeter of thickness all the way around and printed it out of ASA, so we'll see how this one does. Time for a full throttle comparison. Oh no. Well, I think this one wins the durability test. That thing slammed it, and not really even a scratch except dang. Check out that broken propeller. Here's a side-by-side to get a better look at the difference. Pay attention to the voltages. The Molicel sagged all the way down to 3.3, while the Eve sagged down to just about 3.57. Eve hit a top speed of about 97, while Molicel was just 87. Afterwards, the resting voltage of the Molicel was about 3.9 and the Eve was 4.0. Eve 30PL definitely wins this test. Now to answer the question if the camera is worth it, and man, it is a night and day difference, especially on an overcast day. The baby Ratel 2 just does really good in darker settings. The image is just so much more crisp and the lighting is so much better. That being said, it still is analog and you're going to get static, especially when there's things in between you and the quadcopter. Finally, time to pack up to go to the park for some more aggressive flying and then that long range test. The first thing I wanted to test was its ability to do more freestyle-like maneuvers. Now, I'm not a freestyle pilot, but I was pretty impressed with this thing. It definitely has quite a bit more power than my 1S lithium-ion builds. But the real question is, how does it compare to LiPos? Well, I think a good comparison would be to my Pavo 20 Pro. That one runs off a 3S LiPo and it's got a bit more acceleration, but not too much difference. In the cold weather, the Pavo 20 Pro will only run for about 3 minutes, while this will go much longer. And as for handling, I was very impressed, especially with the 3D printed frame. It was pretty smooth. I was surprised to see it almost never got prop wash even with aggressive maneuvers. While I did beef up this frame a bit, I still don't think it's going to be able to take too many crashes, and carbon fiber is going to be much better as far as durability goes. Let's test how fast this thing can go. 98 kilometers per hour. And finally, we're off for another long-range test. I've always wondered how far one of these little 350 milliwatt Zeus VTXs can get us, so we're gonna find out. For my gear, I'm using a Radiomaster Pocket at 250 milliwatts of transmission power, Skyzone O20 Pro goggles, and a Menace RC Omni antenna and patch. On the bottom left, you'll see speed. On the bottom right, you can see distance from home. I'm surprised to see that right away the video quality is getting pretty bad. But I am curious, I think it may be partially related to the antenna that was broken earlier and that I'm still using. Either way, we're gonna push it as far as it'll go until I can't see anything, and then I'll just use my GPS return to home. Well, we've made it past a kilometer, and I'm always so surprised how bad the video can get, and you can just keep going. At this point, I'm doing my best to point those antennas at the quadcopter. I have no clue where they are, but any small head movement is making the video cut in and out. I'm really happy with the amount of battery I have, and I'm really just cruising at 70 kilometers per hour. And this is the point right now where I'm starting to lose my orientation with how bad the video is getting, so I chickened out and hit that GPS return home. I was so surprised to see that the video got super bad on the way back, and I realized I had made a huge mistake. The GPS return speed was way too low, which didn't tilt my quadcopter forward enough. You see, right as I took control and tilted forward, the video got better. This is because it brought the back end of the quadcopter up, putting the antenna into better position. We got the quad back in one piece, so successful mission. Some of you may be asking, what is the flight time of this quad? Sadly, after a particularly bad crash, it no longer flies well enough to properly test. However, based on how it felt in the air, it seems slightly more efficient than this 1S version. I wouldn't be surprised if it could reach over 30 minutes in good conditions. So, is 2S better than 1S? Well, the 2S version absolutely blows the 1S out of the water in terms of power and handling. That extra power opens the door to carrying things like an action cam or GPS. However, the added weight comes with trade-offs. Reduced durability, especially with a 3D printed frame, and the quad is also larger and louder, making it more noticeable in populated areas where your neighborhood Karen might not be too thrilled. And while this build is impressive for a lithium-ion setup, it still can't match the performance of a LiPo-powered quad. Where this quad truly shines is long flight times and moderately aggressive flying.